I mean, sometimes it's pretty obvious, and I think the answer it gives help with like narrowing it down.
Okay,
You only have like four choices, so it kind of narrows it for you.
right.
Um,
Especially if you can eliminate any of the answers, that always helps. Um,
yeah.
tell me a reason you might not want to use the answers.
Um, if you don't solve it all the way, sometimes there might be one step that kind of messes it up and uh like will give you a completely different answer than maybe what seemed the most obvious.
Okay, yeah, you can definitely make some mistakes trying the answers. It only applies to multiple choice. Like there are free response questions, so you can't just always say, "I'm just going to try the answers and everything." That doesn't always work. Think about time. It could go either way. Like it could take a lot of time or a little bit of time. Like if you guess the correct answer, it's not going to take much time. But if you guess wrong, it's going to take a lot of time. And that's
Correct.
actually how I start out this lesson. I talk to you, I just say basically the same thing. Direct solving, which is where you just solve the problem as is, and then find your answer in multiple choice. It can take too much time, especially if you're not sure how to solve the problem. Like if you don't know how to solve it, like you don't want to direct solve. Okay. But on the other hand, you know, on the other hand, truthfully, using the answers can take too much time also, especially if you incorrectly substitute, which you kind of alluded to, or you don't learn anything each time you try and answer. So there is no one size fits all. The decision should always come down to which you think you can do faster. Like if you feel like, okay, faster is always trying the answers, okay, but it's not going to be true on every single problem. All right. And there's this other thing here, learn something from the evaluation. Like you need to really be careful that you're not just randomly trying. You want to learn something each time. Like, is it too big? Is it too small? The something like that.
All right.
Okay, so let's look at an example here. Look at an example problem. All right, so here is your choice. Your choice is like, do I solve this? Do I solve this, or do I try the answers? Okay, what do you think? Which way are you leaning?
What do you mean?
Do you want to directly solve this or try the answers?
Um, and with this one, you can probably just eyeball it. So,
Okay, so again, you can call it something else, but I'm saying let's either direct solve or try the answers. Which one are you going to do?
um, I guess, wait, I guess try the answers.
Okay, so which answer are you going to try first?
Um, Six.
Why six?
Because two times six is 12, and 12 minus four is eight.
Okay, so that's what you meant by eyeballing it, right? Like, and
Yeah.
and that's fine. That's totally fine. If you tried A first, which is what a lot of students do, you would
Uh,
hopefully realize, well, it needs to be a lot larger than A. So you might hopefully jump to C to try next, but you want to learn something each time. All right. Now, another consideration here, I'm going to put the same problem on the screen for you. Another consideration is how many places do you substitute the answer in? Once. Okay, so that's also a consideration here because if you had to put this number in like on both sides or in more than one place, it could maybe change that decision for you. All right, so here's a new question to look at. And what you want to decide here is you look at this, am I going to directly solve it or am I going to try the answers? Notice this time you have to substitute in two places. Which way are
Right.
you leaning? Are you going to try the answers or are you going to solve this?
Probably solve this one.
Okay, go ahead and solve it, please.
A.
Okay, how did you come up with that? You directly solving it 5x minus 15 equals
Yeah.
10x plus 5, just working that out. Great. Yeah, so the answer is A. And if you had chosen A to try, you'd have to plug it in two places and hopefully get the right answer. So this strategy we're talking about, it primarily applies to sort of equations or problems like this where you have to, you have to decide, am I going to direct solve or not? Now, um, sometimes the answer space makes it where it sort of gives you, because of the answers, you may now say, okay, I'm not going to try these answers. Like, I don't want to try fractions, but you might be willing to try the whole numbers. But what happens if these are both wrong? Well, then you've got to try the fractions, or you got to go back and direct solve it. That's why we've talked about this idea that like you got to look over the answers first and be like, okay, there's two fractions, two whole numbers. I could probably solve it because if it is a fraction, then it's there. If it's a whole number, okay, well, I'll get it anyway. That's up to you. You can direct solve, you can try the answers.
Right. Um, 8.
The answer is eight, yes. All right. Now, a typical student here, when I'm doing these examples, they are just trying the answers every time. They're like, I'm just going to try the answers. And here's an example of a problem where you do not want to try the answers. That you will never, 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 never get the right answer if you try the answers. So this problem has to be done by direct solving. There's absolutely no way to do it, without working in it. Okay. And this one requires a lot of effort. Like there's a fair amount of effort, lots of places to make mistakes. What do you think you should do if you work this all the way down and you get a number that's an answer that's not here? What would be your first thought?
Um, I don't know.
Okay, we will talk about that. We'll talk about that. So the way to solve this problem here is you first want to eliminate the fraction. Okay, and the way to do that is to recognize that you're really dividing the whole thing by 6 and the whole thing by 9. So the least common multiple between 6 and 9 is 18, and that's what you want to multiply everything by here. I'm going to grab a different color to show that. You want to multiply both sides by 18. But what that does is it reduces because 18 over 6 is 3, 18 over 9 is 2. So you get down to 3 times 5k plus 2 minus 7 equals 13 minus 4 minus k times 2. So let me get the parentheses around that. All right. So from here, it's more doable. And I think there's a sort of confusion here about how many terms are actually inside parentheses. To avoid that confusion, let's just multiply in here. So it's 5k plus 10 minus 7 times 3. And on the right here, it's 13 minus 4 plus k times 2. And if you're okay up to this point, you would then multiply the 3 into everything and the 2 into everything. So you got 15k plus 30 minus 21 equals 26 minus 8 plus 2, 2k. So I'd like you to solve it from here
Okay.
and get k by itself.
Okay, I got 9/13.
This is a pretty challenging problem. It would be okay if you got this one. You're just like, I don't know if I can do this, but you can always try. You can always do something, right? And if you work on this type of problem again, maybe you'll have a better chance of solving it. So let's look at another problem here. We're just kind of looking at this idea, like whether it's better to direct solve or to try the answers. So this is an example of a problem where if you're going to try the answers, you want to look at this and you're realizing like, oh, I'm actually squaring a number. That might be a tough deal if you don't have a calculator on these two. So like you might say to yourself, well, if I'm going to try the answers, I should try the ones that are smaller. But that's only, kind of a guess, a direction. You're not for sure on this. If you do have to solve, you have to remember how to solve quadratics. So either is okay. Go ahead and try this one and let me know what you come up with.
Got 9.
It is 9. Good. All right. So here is an example, another example here, where again, you got to decide, like, hey, do I feel comfortable trying the answers? Do I want to try to direct solve it? Which is going to take me more time, which is going to take me less time. So take another look at this one. Take a look at this one. Another thing that might be important here is that you can only take the square root of certain numbers. You can't take the square root of anything. That would also be an important consideration here as well.
Is it 6?
It is 6. Yeah. Now, the whole idea of like what can you take the square root of is really important here. Because you might think, oh, I could take the square root of 4 and I could take the square root of 1, but it's that number plus 10. So you really almost need to add 10 to each of these
Yeah.
and decide, well, which of these can you actually take the square root of? And you'll find it's actually only the first and the fourth. All right, let's try another one of these where, again, you got to decide, am I going to try the answers or not? And you're probably leaning towards, okay, I'm just going to try the answers. And that's not a terrible strategy. Um, this one, though, you have to try the answer in 3 places. One, two, 3 places. That could maybe say, well, maybe I can do something to solve this.
Fair.
Um, Not sure. Like you got to kind of decide if that's a bother or not.
6 or
let's take
3.
which one is it?
3.
Okay. How did you come up with 3? Did you just try the answers or not, or solve it?
Wait. No, I kind of just like uh factored.
Okay, good. That's good. Like if you just do like one step, if you subtract 2x squared from both sides, you get 4x equals 3 plus x squared. And this is better. You're better off trying your answers here because now it's only in 2 places, right? So is 4 times 3 the same as 3 plus 3 squared? And it is. Very good. So like just doing like a one thing could really make a big difference there. All right. I was hoping to find a couple more square root problems because these square root problems tend to be, but not difficult, but they appear difficult. Let's see if I can find a couple more that it's for you to try. Yeah, there we go. All right. Okay, so here is an equation with a square root in it. Remember from last time, like there's only certain things you can take the square root of, but keep in mind you're subtracting 5 here. So it's almost like you want to subtract 5 from all the answers and then decide, well, you know, do any of those still work? 6, 4, 11, and 16. So these you can take the square root of, but not the others.
Hmm.
Right? Because 9 minus 5 is 4. You can take the square root of 4. 21 minus 5 is 16. You can take the square root of 16.
Oh, 21.
So yes, the answer is D. All right. So keep that in mind. I'm going to give you another couple of problems here to solve. That was kind of the vanilla easy one, but here's one like it. You tend to see these on the standardized tests, these root problems.
Nine.
There's nine. Good. One or two more here. And these are good ones to try the answers. There's not a lot of direct solving in these.
Um, Two.
Two. All right. So we've talked at length about trying the answers. And we've even talked about how, like, well, maybe you don't try the answers on every single problem, um, especially if they're fractions. Here is a problem that it actually is better still to try the answers, um, even though maybe because they're fractions, you're like, "Ah, I don't know if I would do that." The reason is that the answer is a fraction. You've got a, 3/5 times something gives you 4/3. Um, that's not great to begin with. So let me try A, so you can see how this works. 3/5 times 9/20. You end up multiplying the tops and the bottoms, but you first look to see if you can pre-reduce, which is reducing before you multiply. And there's nothing that goes in the top and bottom. Like 3 doesn't go into 5, or 9 and 20, or 9 and 5, 3 and 20. You get 27/100. This does not equal 4/3. But so A is out. We didn't really learn anything though. We just learned that, hey, it'd be nice to see if we can cancel some things. So it's up to you. You can direct solve this or try the answers, but look this over. This will be the last one before we move on to something else for today.
Um, 20/9.
It is 20/9. Good. All right. Um, I actually misspoke. I have a number of other problems here that are in this group. Are you okay to keep solving some for today's lesson before we move on to a math subject area? Can we do a few more of these?
Yeah.
Okay. All right. So these are going to have some similarities to the ones that we've already done. What I'm going to do though is get the timer out, and I'm going to let you know when a minute is up if you haven't solved it yet, and just to kind of say, okay, let's see if you need more time. All right, go ahead and try this one, please.
-8.
All right, so your answer is -8. You are correct. So you got this one often throws students off. So I'm glad you're able to figure that out here without did you have any hesitation about your answer?
Uh, at first a little, but
All right. All right, so here's one that I would recommend because the answer is all fractions, directly solving it?
Um, -2/9.
Okay. Tell me what you did first to solve this. What did you do first here?
Um, I just like collected the terms.
Okay, but they're on the opposite sides, so you can't collect them.
Yeah,
You,
like
you either
move,
which
you
which
move it.
which one did you move? Did you move 2p or 7p or 8 or 6? What did you do first?
7p, and 6.
Okay. Tell me what you got on the left and the right side.
2p. Wait, 2p minus 7p equals 8 minus 6.
Sure, but yeah, what is 2p minus 7p though? What is the result
Oh,
of that?
-5p.
Negative 5p equals, and what is 8 minus 6?
Uh, 2.
Okay, do you want to change your answer?
-2/5.
Yes. All right, so let me give you one like this, just to try again here. Let's say it's 4y minus 9 equals 6 plus 2y. Can you solve this for us, please?
Um, Y equals 15/2.
Very good. Okay. Any questions, thoughts on that before we proceed?
No.
I'll be right there. Thank
All
you
right,
so
so here's another one where you can it's not really obvious which way to go. You either direct solve, which is fine, or you try the answers. I'll leave that up to you on this one.
All right.
I'm gonna go pick up the pups. I'll be right back.
All right. Um, 8.
Oh, how confident are you in your answer?
Pretty confident.
Yep, it is 8. Your time's really good. Whether you've been right or wrong, you've not been like overdoing it with time. The traditionally students take too much time, and whether they get the answer right or wrong, I mean, it's you got to eventually,
Yeah.
you know, worry about that. All right, so let me give you a new problem here to try. And I'm gonna give you a minute to solve this. If you don't have the answer in a minute or aren't sure, I'm gonna give you the hint that will help here.
Man. 15 over 2.
Excellent. Wow. So the hint was going to be to combine 7 times 2x minus 5 and this one right here to get 5 times 2x minus 5
Yeah.
equals 4 times x plus 5. Um,
Yeah.
the
Distribute.
Yeah, now you could. Now, if you look at the answers, this one's way too big. Like it's rare when the answer's like that. So you might try one. One doesn't work either. And so you're down to these two. Um, you know, it's not the best to try the answers. It really is better to do what you said, which is distribute and solve. So good job on that. Couple more square root questions, and then we'll talk about
64. Hmm.
Okay, so to kind of summarize the strategy here, to decide whether to direct solve or use the answers, it obviously only applies to multiple choice. Like you can't apply it for response questions. What you're trying to decide is whether it is faster to solve or try the answers. You always want to figure out, like, if you try the answers, like, did you learn something? Is it too big, too small, way off, things like that. And truly, like, these are all paired with another strategy. Like, if you're going to try the answers, maybe look back at the problem and see if there's something else that you can learn from it. Like, oh, I've got to substitute in 8 times. I probably shouldn't do that. Okay, so the next just thing that you maybe haven't done in a while is the quadratic formula. So believe it or not, you get questions on the test, which are just a pure solve this using the quadratic formula. Do you remember anything about quadratic formula?
Hardly.
Okay. So this is one of those, like, where if you know the formula, you'll get one more problem correct than you would have without knowing it on the test. That's a good thing. It really is a good thing. Okay. So let's look at a very basic question. Let's look at x squared plus 2x minus 3 equals 0. And let's use the quadratic formula to solve this. Ax squared plus bx plus c equals 0. What's the value of a? What's the value of b? What's the value of c in this problem? Is it clear what I'm asking you to do here?
Yeah.
Okay. So what's the value of a? What's the value of b? What's the value of c?
A is 1.
Okay.
C is -3.
Okay.
And B is, oh, 2.
Two. Good. All right, so the quadratic formula is minus b plus or minus the square root b squared minus 4ac all over 2a. And it's probably worth memorizing this. This is one of those, again, like you'll get one more question right than you would have before otherwise. And that could be the difference. So I would definitely recommend that. So the way this works though is you really are substituting the variables like as if they're in parentheses. So it looks like this: minus 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 3 all over 2 times 1. That part in under the square root is the most important. So could you tell me what the part under the square root reduces to?
Um, 1.
So we have 2 squared is 4, and then 4 times 1 times negative 3, that's negative 12. I get that it becomes the square root of 16. Two squared is 4. 4 times 1 times negative 3 is negative 12. Do you agree with me? You see where I got that?
Yeah.
Okay. So can you reduce the square root of 16?
Yeah.
Okay. What does that become?
Like
What is
4.
this for? So it's really negative 2 plus or minus the square plus or minus 4 over 2. This is really two numbers. It's really negative 2 plus 4 divided by 2, negative 4 minus 4 divided by 2. Could you reduce those for me, please?
1 and negative 3.
That is correct. All right. Very good. All right. Let's do another one here. Quadratic formula. I'm choosing ones that work out nicely, and then we'll move to some that do not work out nicely. Could you give me the value of A, B, and C, please?
A is 1. Oops. B is 3.
Okay.
And C is negative 10.
All right. So the formula is minus B plus or minus the square root B squared minus 4AC all over 2A. I recommend doing the part under the root first. So why don't you do this part under the root first for me, please? Tell me what you come up with. All right, what do you have for the part under the square root?
Um, 2.
How did you come up with 2?
2 times 1.
Under the square root is this b squared minus
Oh, yeah,
4ac.
yeah, yeah. Sorry.
That part.
9
Maybe
plus
that's
40.
maybe that's what you meant earlier. Okay. Yeah, what is 9 plus 40?
49.
Okay, so this is -3 plus or minus the square root of 49 all over 2. I want you to simplify and give me the 2 answers.
Negative 3 plus 7 over 2. And negative
Go
3
ahead.
minus 7 over 2.
Yeah, go ahead and reduce that, please.
Negative 5 and 2.
Very good. All right. Good job on that. So the examples I just gave you, they don't actually require quadratic formula, but you will see a problem that does. This is an example of one. X squared, x plus x squared minus 1 equals 0. In this problem, a is 1, b is 1, and c is -1. I'll put the quadratic formula up here. I'd like you to try this. This time, the part under the root does not reduce. Does not reduce. So you just get the square root of something inside there. So go ahead and put these numbers in and let me know what you come up with. What are you doing on this one?
Fine.
Okay. You have an answer for me?
Yeah.
Okay. What did you get under the square root?
Um, -3.
Okay. It's 4 times 1 times -1, which is -4. And if you put that negative with it, it ends up being +4. I get 1 plus 4 ends up being -1 plus or minus the square root of 5 over 2. All right, we will do a few more problems like that next time.